The National Electrical Code, specifically Article 250.104 A2, addresses equipment grounding when using conduit. This section states that conduit, tubing, and fittings can be used as an equipment grounding conductor if the following conditions are met. Firstly, the conduit or tubing must be continuous from the point of attachment to the equipment, extending all the way to the service equipment or grounding electrode system. Secondly, all locknuts and couplings must be made up tight as required by Article 100. It's important to note that the NEC doesn't explicitly mandate the use of grounding locknuts that have screws for EMT connectors. Underwriters Laboratories, also known as UL, plays a crucial role in safety testing and certification. EMT connectors are UL listed to meet certain standards. These standards ensure that the connectors provide a continuous electrical path, which is essential for grounding purposes. While the NEC doesn't specifically require grounding locknuts with screws, they are often used as a best practice to ensure a reliable electrical connection. This is especially relevant in high voltage applications such as systems operating at 480 volts. One potential explanation for an inspector's statement about requiring grounding locknuts is that they might have misunderstood or misquoted information received at a seminar. It's also possible that the jurisdiction in question has adopted a local amendment to the NEC that specifically requires grounding locknuts in certain situations. To clarify the requirement in a specific location, the best course of action is to contact the electrical inspector directly. You should request that they provide a code reference or any other documentation that supports their interpretation and requirement. If the issue remains unresolved, it may be necessary to escalate the matter to the local building department or the state electrical inspection authority for further clarification. The NEC provides general guidelines, but local jurisdictions can sometimes have their own specific amendments or interpretations. It is always best to check with the local authority having jurisdiction to verify code compliance. The primary function of equipment grounding is to provide a low impedance path for fault current to return to the source. This facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault. A reliable ground connection is vital for safety, protecting individuals from electrical shock hazards and preventing damage to equipment. When installing EMT conduit, proper techniques should be followed to ensure a continuous and effective ground path. This includes ensuring that all connections are tight and that conduit fittings are properly installed. In situations where vibration or movement is anticipated, using grounding locknuts with screws can provide an extra level of assurance that the ground connection will remain intact. The type of equipment being served by the EMT conduit also plays a role in determining the appropriate grounding method. For sensitive electronic equipment, a dedicated equipment grounding conductor might be necessary to minimize electrical noise and ensure proper operation. In some cases, it might be beneficial to supplement the EMT conduit with a separate grounding conductor, even if it is not strictly required by the NEC. This can provide an additional level of protection and redundancy. When working with electrical systems, it's always best to err on the side of caution and implement the most robust grounding methods possible. This not only ensures compliance with the NEC but also provides a safer and more reliable electrical system overall. Furthermore, proper grounding practices contribute to the overall longevity and performance of electrical equipment. By minimizing the risk of ground faults and electrical noise, grounding helps to prevent premature failures and extend the lifespan of electrical components. To ensure effective grounding, it's essential to inspect and test the grounding system regularly. This includes verifying the continuity of the ground path and checking the impedance of the grounding electrode system. Any issues or deficiencies should be addressed promptly to maintain the integrity of the grounding system. In addition to the NEC and UL standards, there are other industry standards and best practices that provide guidance on equipment grounding. These resources can offer valuable insights and recommendations for specific applications and situations. Consulting with experienced electrical engineers or contractors can also be helpful in determining the most appropriate grounding methods for a particular project. They can provide expertise and guidance based on their knowledge and experience. When selecting EMT connectors and fittings, it's important to choose products that are specifically listed and labeled for grounding purposes. These products are designed and tested to meet the requirements of the NEC and UL standards. Using the correct tools and techniques for installing EMT conduit is also critical for ensuring a proper ground connection. This includes using conduit benders to create smooth bends and avoiding sharp edges that could damage the conduit. Additionally, proper reaming of the conduit ends is necessary to remove any burrs or sharp edges that could interfere with the connection. When installing Locknuts, it's important to tighten them securely to ensure a good electrical connection. However, over-tightening can also damage the conduit or fittings, so it's important to use the appropriate torque. In corrosive environments, special precautions may be necessary to protect the EMT conduit and fittings from corrosion. This can include using corrosion-resistant materials or applying protective coatings. Regular maintenance and inspection of the EMT conduit system can also help to identify and address any corrosion issues before they become a problem. The size of the EMT conduit also affects its ability to serve as an equipment grounding conductor. Larger conduits have a lower impedance and can carry more fault current. The NEC provides guidelines for selecting the appropriate size of EMT conduit for grounding purposes. In some cases, it might be necessary to use a larger conduit than would otherwise be required for the circuit conductors to ensure adequate grounding capacity. When multiple circuits are run in the same EMT conduit, it's important to ensure that each circuit has its own equipment grounding conductor. This can be accomplished by running a separate grounding conductor with each circuit or by using a common grounding conductor that is sized to accommodate the fault current of all the circuits. The location of the grounding electrode system is also important for ensuring effective grounding. The grounding electrode should be located as close as possible to the service equipment and should be connected to the building's metal water pipe or other approved grounding electrode. The grounding electrode conductor should be sized according to the requirements of the NEC. In some cases, it might be necessary to install additional grounding electrodes to achieve the required grounding resistance. The NEC provides guidelines for determining the number and spacing of grounding electrodes. When installing a new electrical system or modifying an existing system, it's always best to consult with a qualified electrical contractor or engineer. They can provide expert advice and ensure that the system is installed in accordance with the NEC and local codes. They can also help to identify any potential grounding issues and recommend appropriate solutions. The use of surge protective devices, also known as SPD, can also help to protect electrical equipment from damage caused by voltage surges. SPD should be installed at the service entrance and at any other locations where sensitive electronic equipment is located. Proper grounding is essential for the effective operation of SPD. In summary, equipment grounding in EMT conduit systems is a critical aspect of electrical safety. While the NEC doesn't explicitly require grounding Locknuts with screws in all cases, they are often used as a best practice, especially in high voltage applications. Consulting with electrical inspectors, engineers, and contractors can help to ensure that the grounding system is installed in accordance with the NEC and local codes. Regular inspection and maintenance of the grounding system are also essential for maintaining its effectiveness. By following these guidelines, you can help to ensure a safe and reliable electrical system. The National Electrical Code is updated every 3 years, so it's important to stay current with the latest requirements. Changes to the NEC can impact grounding requirements and other aspects of electrical installations. Subscribing to industry publications and attending training courses can help you stay informed about the latest changes and best practices. Furthermore, many online resources provide valuable information about electrical grounding and other electrical topics. These resources can include articles, videos, and forums where you can ask questions and get answers from experienced professionals. However, it's important to verify the accuracy and reliability of any information you find online before relying on it. In addition to the technical aspects of equipment grounding, it's also important to consider the human factors. Electrical safety training should be provided to all personnel who work on or around electrical equipment. This training should cover the hazards of electricity, proper grounding techniques, and the use of personal protective equipment. Regular safety audits can help to identify potential hazards and ensure that safety procedures are being followed. By prioritizing safety, you can help to prevent electrical accidents and injuries. Finally, remember that equipment grounding is not a one-size-fits-all solution. The best grounding method for a particular application will depend on a variety of factors, including the type of equipment being served, the voltage level, the environmental conditions, and the local codes. Consulting with qualified professionals and following industry best practices can help you to develop a grounding system that is both safe and effective. They can also help to ensure that the grounding system is properly documented and maintained.